Welcome to True Projects. In this video, we are going to explain about the project, which is an effective classification of DDoS attacks in a distributed network by adopting hierarchical machine learning and hyperparameters optimization techniques. Before getting into the execution, first let us understand what is the project about. The advancement of technology has really changed how we interact with the essential services like banking, insurance, and utilities. Everything is so much more convenient now because we can handle most of the things online or through mobile apps. But this shift towards digitization comes it with own set of challenges, especially when it comes to the part of cyber security. For instance, distributed denial of service that are nothing but DDoS attacks have become more significant threats. So these attacks essentially flood a server with fake requests, overloading it to the point where legitimate users can't access it. Now, this isn't just about an inconvenience. It is about seriousness, especially in industries like banking. Think about how interconnected financial networks are. If one system is compromised, it doesn't stop there. It can impact other systems too, causing a chain reaction of issues. This is why tackling the issues is very important. So, this is why tackling these types of cyber threats has become so crucial as they don't just disrupt services, but they also put up sensitive data and the personal data at risk and also the financial information at risk. So, traditional security measures they often struggle when it comes to telling the difference between legitimate and malicious attacks. So these attacks they flood network with traffic, making it hard for traditional tools to differentiate between what is real and what. So this is where machine learning comes into the picture. It can really make a difference. ML can analyze patterns in the network traffic and also it can help in identifying malicious activities more accurately by learning from the past data. But even with ML, there are challenges. The models need to be optimized for better accuracy and efficiency, which isn't always easy. Fine tuning these models to improve their performance is crucial. By addressing these challenges, we can build stronger systems that not only enhance security, that is data security, but also better protect online services from growing threats posed by DDoS attacks. So, the proposed system takes an hierarchical machine learning based approach to tackle the challenges of distributed denial of service attacks. First, it begins with pre processing the data from CIC IDS 2017 dataset. This involves min-max scaling, normalizing the data, which helps bringing values to consistent scale for better processing. Additionally, synthetic minority oversampling technique is applied to address any class imbalance, where some classes may be unrepresented in the dataset. After pre-processing, the system uses least absolute shrinkage selection method that is nothing but lasso. This method is used for feature selection. This technique helps by reducing the dimensionality of the data, filtering out less important features, and focus on the most critical ones for more accurate and effective classification attacks. So, this hierarchical approach helps the system classify DDoS attacks more efficiently and with higher accuracy. One important feature after once important features are selected, they are processed through a series of powerful machine learning models that are nothing but XGBoost, CAD random forest, and decision tree. Each of these models are fine-tuned through hyperparameter optimization techniques. So these are all fine-tuned to improve the to maximize the performance so that they can ensure accuracy effectively. That is, they can function as effectively as possible. The models are then evaluated by using the key metrics that are nothing but accuracy, precision, recall, and FN score to measure how well they can detect these attacks. So, this approach provides a robust and efficient solution for detecting and preventing DDoS attacks. It not only ensures the accuracy of detection but also plays a crucial role in protecting data privacy and security, particularly in high stakes sectors such as finance, where safeguarding sensitive information is utmost important. To further improve the performance, we have incorporated voting classifier as the extension of the model, which is the ensemble model. This method combines the predictions of multiple machine learning models, leading to more reliable and accurate results when classifying DDoS attacks. By leveraging the strengths of each model, ensemble approach ensures that final classification is more precise. Additionally, front end of the project is built using Flask framework. This provides a secure platform for user authentication and offer intuitive user-friendly interface where users they can test the system and also analyze the results of the intrusion detection process. Moving on to the implementation of the project, we have followed the steps of the flow of work. Let's understand them. So the first step that we have done is we have imported the packages. So the first step involves importing the libraries, necessary libraries like pandas, numpy, scikit-learn, and other machine learning tools needed for data processing, model training, and evaluation. Then we have loaded CIC-IDS 2017 dataset. So in this step, CIC-IDS 2017 is loaded and initial exploration is done to understand its structures, columns, and its types of data in the columns. Coming to data processing. Here, duplicate entries are identified and removed to ensure that dataset remains clean and does not skew model results. And irrelevant or missing values are dropped, ensuring only useful data is used for training. Coming to data visualization, this step involves creating visual representations like graphs and charts of the data to identify patterns and correlations, helping in better understanding of the dataset. Coming to label encoder. Here, categorical data is encoded into numerical values using label encoding to make it suitable for machine learning models. Then we have selected important features using LASSO, that is nothing but least absolute shrinkage and selection operator. So this technique is used for feature selection to identify and retain the most important features, improving model efficiency. And we have applied SMOTE technique, that is nothing but synthetic minority oversampling technique. It is applied to balance the data set by generating synthetic minority samples, examples of minority class, which helps the model to learn better. Then we split the data into training set and testing set. The training set is used to train the model and validation set is used to evaluate its performance. Then here we build different machine learning models are chosen and prepared for training. Then the selected models are trained using the training data, allowing them to learn patterns and features relevant to intrusion detection. And we compare all those using this accuracy, precision, recall, and defense score. So first we used all four metrics to evaluate and then we compare them. And we compare them in using graphs also. And we have developed front end using Flask framework along with registration and login with the support of SQLite, the database. So the backend uses SQLite for storing the user credentials and the other data. The next part is users, they will be able to give input feature values in the front end and that will be pre-processed at the back end. Train model will be fed to this data and then finally outcome will be displayed in the front end, which type of attack it is. Moving on to the algorithms used, these are the algorithms used to detect the attacks. So these are the models proposed in the base paper. So these are the models used. These are the proposed models. And here, this is the extension model that has achieved highest accuracy. So we have used it in the front end to detect the attacks. Moving on to the requirements. To implement this project, we need hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end language, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute. To execute, we need to open the code folder which contains source code files. Let's open the code folder. These are the source code files in the code folder of the project. And here in the CIC IDS 2017, we have the dataset used in the project. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files. These are important for the visual appeal of the project. Coming to templates, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have model file which contain the algorithm information, and this will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. And here in the sample file, we have the test cases that we will be using in the front end to detect the attacks. And in this processed file, we will be having the data after pre-processing. So this is the data after pre-processing and applying the imbalancing technique, SMOTE technique. So this is the data used to train the models for detecting the attacks. Last, we have label column, which is the target column. Here we have different types of attacks, and these are the features that are important for this label. Let's close this. Now, copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. So here Anaconda prompt is open. Now use the command cd, give the space, paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folders path. So by giving the command cd, current directory will change to the code folders path. Now give the command python space app.py for compiling the app.py file. Click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework. I'm copying the link. Now paste it in any web browser. Paste the link here. Click on enter. So this is the web page of the project, which is displayed in the browser. This is developed using Flask framework. So now we need to sign up. First, click on sign up and enter all the registration details if you are registering newly. I have already registered. I'll log in directly. Click on login. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. Here first we have is init BWD win bytes that are nothing but it represents the initial number of bytes in the backward direction from the destination to the source of the flow used to analyze the initial data exchange in network connection. Next, we have init forward win bytes. It refers to the initial number of bytes in the forward direction that is from source to the destination of flow, helping in analyzing how much data is initially sent from the source. Coming to flow packets, it is the rate which packets are transmitted in the flow measured in packets per second. It indicates the packet throughput in the network. Then we have packet length variance. It measures the variations in the packet sizes within the flow, providing insights into the stability and uniformity of the data transmission. Then we have flow bytes. It is the rate at which bytes are transmitted in the flow measured in bytes per second. It reflects the data throughput of the network connection. Then next one we have is flow IET mean. It is the mean that is average inter-arrival time between packets in the flow indicating the average time interval between consecutive packets. Then we have ideally mean. It is the average amount of ideal time between packets in the flow which can help to identify periods of inactivity or potential network bottlenecks. Then we have ideal max. Idle max, it's the maximum amount of idle time between packets in the flow used to detect unusual long gaps in the data transmission. Then we have backward IET min. It is the minimum inter-arrival time between packets in the backward direction, that is from destination to the source, indicating the fastest response time in the reverse flow. Then we have is idle min. It is the minimum ideal time between packets in the flow, identifying the shortest period of inactivity. So these are the packets. I mean, here, these are the packets that we're supposed to enter. We got all these parameters are right. Now let's enter them. For that, let's open the sample file in which we have test cases. So these are the test cases that we will be entering. Here we have different types of attacks. So let's apply filter to this label column. So here we have total 7 types of attacks. Let's try one by one. So first, let's try with the zero class label. Click on OK. Now let's enter this first case, where init backward bytes are -1, init forward bytes are -1. The next one is flow packets. So let's copy it. The next one we have is packet length variance. Next one is flow bytes. The next one is flow IET. mean, and the next one is idle mean. It is 0. So the rest all values are 0. Let us enter them. Now click on predict. So here we got the prediction that there is no attack detected and it is benign. So there is no attack. Completely the transaction, that is the flow, is benign. That means there is no attack in this particular values. Let's try to enter one more test case. Let's try to give the first case, first class label. Click on OK. So let's enter here. Init backward when bytes are 227. Init forward when bytes are 292.00. The next one is flow packets, packet length. Flow bytes are 33.35. Flow IAT mean, idle mean, idle max, backward IAT, idle min. Click on predict. So here we got the prediction that attack is detected and it is bot attack. So by giving all these inputs based on the given input, here we got the prediction that bot attack is detected. Now let's try with the other case. Let's try with the class 2, where initial backward bytes are 236, initial forward bytes are 237. Next flow of packets are 44,444.4. Next one here we have is packet length is 0. Forward bytes are 0. 45 is the flow IAT mean. And here ideal mean is 0. Ideal maths is 0. Backward IAT mean is 0. Ideal min is 0. Now let's click on predict. And here we got the prediction that attack is detected and it is brute force attack. So here we got the detection brute force attack. Now let's try with the class 3. Let's try with the first case of class 3. So here initial backward bytes are 229. Initial forward bytes are 8192. The next we have is flow packets. So here we are supposed to give the flow packets, packet length, give the packet length, flow bytes, flow IIT mean, idle mean, it is 0. The next we have ideal max is also 0. Backward bytes are 3. Idle mean is 0. Click on predict. So here, based on the given prediction, here we got that DDoS attack is detected. So here attack is detected and it is DDoS attack. Let's try giving one more test case of the same attack and see whether it will correctly predict or not. Let's give the initial bytes are 229. Initial forward bytes are 256. And the next flow packets are 0.17. Packet variance is 266 point change. And the next one we have is flow bytes, flow IET mean, ideal mean, idle max, backward IET min, and idle min. Now let's click on predict. So here also we got the prediction that DDoS attack is detected. Let's try with 3 more cases which are pending. Let's select class 4, click on OK. And now let's enter them. Click on prediction. Let's give those values. So where initial backward bytes are 235, initial forward bytes are 256. Flow packets are 0.145. Packet length variances. Here we have entered flow bytes. Flow IIT mean, idle mean, idle max, backward IIT min, idle min. Click on predict. So here we got the prediction that attack is detected and it is DOS attack. Initially DDoS attack was detected and here only DOS attack is detected. Let's check with last two cases. Click on OK. So let's give these inputs. Here initial backward bytes are 0. Initial forward bytes are 29,200. Flow packet size is 0.05. Packet variance is 10.8. Flow bytes, flow IIT mean, idle mean, idle maths, backward IIT min, idle min. Now click on predict. So here we got the prediction that attack is detected and it is port scan attack. So here we got the detection of port scan attack. Let's try with the last case. That is the 7th type of attack. So here copy the initial backward 1 bytes, flow packets, packet variance length where it is 0. Flow IIT mean copy the value. Idle mean is 0 and rest all are 0. Click on predict. So here we got the prediction as attack is detected and it is web attack. The attack type is web attack. So now let's check with the graphs. Click on graph. So this is the sample outcome graph. First we have as a sample outcome graph where on x-axis we have all the types of classes and on y-axis we have the count. Classes are nothing but different types of attacks. Here if you observe, benign that means normal cases where there is no attack cases are more than the attack cases. So that is why we have applied the mode technique, that is the class balancing technique. And this is the correlation matrix that shows the correlation between variables. And here we have accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are built. So here we have built all the algorithms without hyperparameter optimization and with hyperparameter optimization technique. And here is the extension part which has achieved the highest accuracy. Moving on, here we have classification performance, that is precision comparison graph. Here on x-axis we have precision score and on y-axis we have all the algorithms built. And here we have recall score. This is the FN score comparison graph. Here accuracy, precision, recall and FN score are the error metrics used to evaluate this classification models. Now sign out. In this way, just by giving inputs to the system, the trained model will be giving us the prediction. By this, it mitigates the cyber attacks by detecting early itself. This is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.